Hello. Okay, so let's have a quick look at the first question. Now, for this question, you could have used these words more than once, and they did appear more than once, actually. So, the center of the atom is the nucleus. The two types of particle in the center of the atom are the proton and the neutron. James Chadwick proved the existence of the neutron. Niels Bohr suggested particles orbit the center of the atom. This type of particle is the electron. The two types of particle with the same mass are the neutron. So a neutron has a relative mass of 1, and so does the proton. So it was a mark for each correct answer, and it was out of 5. Very nice and simple to start the exam with. Over the page, this question asks us which of these is the plum pudding model. Now, the plum pudding model is obviously not that, nor that, nor that, and I think there would have been a little bit of confusion about whether it was B or E. J.J. Thompson, who proposed the plum pudding model, had actually discovered electrons, and he thought that the vast majority of the atom was a cake, or rather that the cake in his model represented positive charge, and then he realized that there were some negative charges dotted through, which he thought, were kind of resembled the raisins in a plum pudding. So it was actually B and not E, because the tiny little dots, tiny little plums in his pudding were negative electrons. The first answer was B. Next answer, which diagram shows the model of the atoms developed from the alpha particle scattering experiment? The alpha particle scattering experiment discovered neutrons. Remember, alpha particles, which had positive charges, were fired at this atom, and the alpha particles went straight through for the most part, because most of the atom was empty space, and then it hit a positive nucleus in the center where the alpha particles were deflected. So clearly it's not that, clearly it's not that, clearly it's not that. So then we're thinking this one or this one. When the alpha particle scattering experiment was taking place, we then, off the back of that, found out about a positive nucleus. We didn't yet know about neutrons or anything like that, which this model shows. So it was C. The next question, which diagram shows the model of the atom resulting from Bohr's work? Now, Bohr discovered the electron shells around the outside, so this one. And finally, 2D, the mass number of an atom tells us the number of protons and neutrons. And there was me making a little mistake there, not reading the question properly. Okay, so over the page, the answer of the relative atomic mass of element X is between 69.5 and 70. Chadwick's experimental work on the atom led to a better understanding of atoms. Explain how his work led to this understanding. Now, Chadwick provided the evidence to show the existence of neutrons, so that was really important. His work led to show that there were neutrons in an atom. This was necessary because isotopes have the same number of protons, and so essentially what happens is that in an isotope you have the same number of protons, the same number of electrons, but a different number of neutrons. Moving further down the page, by the early 20th century, protons and electrons had been discovered. Describe how knowledge of the numbers of protons and electrons in atoms allowed chemists to place elements in their correct order and correct group. If placed consecutively, so that means in order, then elements would be in the wrong group or have wrong properties, okay? So if they were in perfect ascending order of proton number, then they would be put into the wrong groups. So what Mendeleev did was leave gaps, and he actually switched a lot of elements around that didn't quite fit with the properties in that group. So he prioritized properties before any kind of atomic number or mass number. Over the page, we have John Dalton. He thought that all substances are made of a vast number of extremely small particles called atoms. Every particle of water is like every other particle of water. every particle of hydrogen is like every other particle of hydrogen, and so on. So we use Dalton's ideas and your knowledge of water to explain why. So water molecules contain two hydrogen atoms, that's your first mark, and one oxygen atom. So every single molecule of water will have two hydrogen atoms and one oxygen atom, because of course water has a chemical formula of H2O, which means that every molecule of water looks like this, with two hydrogen atoms and one oxygen atom. Okay, further down the page, the diagrams represent two atoms of hydrogen. State in terms of particles how these two atoms are different. Right, okay. So atom A has no neutron and atom B has a neutron. So can you see atom A just has a little proton and it doesn't have any a neutrally charged particle in its nucleus, whereas atom B does have a neutron. Over the page, question 5, it says the model that Thompson proposed was called the plum pudding model. Describe this model. So Thompson's plum pudding model, as we've already kind of talked about before in this video, looked like a piece of cake, otherwise known as a plum pudding, kind of looked like a Christmas pudding, where the cake was all positive, and then you had these raisins that were negative. Okay, so the cake, the pudding part, was positive, and then there were these negative charges dotted through, which Thompson called electrons. So electrons dotted through the atom here as the raisins, surrounded by positively charged pudding. So the rest of the atom was positively charged. So a mark for each of those. Moving down the page, explain what led to the plum pudding model of the atom being replaced by the nuclear model of the atom. Okay, so the nuclear model of the atom suggests that there is a nucleus in the center and that nucleus is positively charged. So plum pudding model suggested that the atom was a sphere of positive charge with negatively charged electrons dotted through. That's what I've just described here. So at first we're describing the plum pudding model. Now we are talking about how the alpha particle scattering experiment replaced this plum pudding model with a more nuclear model of the atom. So the alpha particle scattering experiment was where positively charged alpha particles were fired at a sheet of gold foil. The positive alpha particles mostly went straight through the atom, proving much of the atom was empty space. And finally, some alpha particles were repelled by the positive nucleus and were deflected, proving the existence of a positive nucleus. So that tells us what the plum pudding model was, the experiment that led to a more nuclear model, and essentially what that nuclear model was at the end. Just to jog your memory, what happened was atoms, so we've got this positive nucleus in the middle, and we've got all these negative charges around the outside. Alpha particles, which have a positive charge, were fired at this atom, and most of them went through, but some of them were deflected. So some of them bounced off the nucleus, and they were repelled by the nucleus because alpha particles were positive, the nucleus was positive, so they were repelled, so they deflected from the nucleus, and that proved that there was a nucleus in the center that was positively charged, and that the rest of the atom, where all the alpha particles went straight through, was actually empty space. And there we have it. That is your exam.